All right, welcome back to this is a China TST polynomial. So I want to show that for every okay, you just have a polynomial p, okay, and p0 is given to be 1. If I okay, let me make sure the thing actually. You're given p0 x 1. I don't think this matters because p0 is plus minus 1 and you can negate. But okay, let me just write down what it is. So you're told that x plus 1 times p of x squared minus 1 is equal to so odd means that this is like negative of let me write 1 plus x so that's a little less annoying. 1 plus x and then plus 1 minus x times p of minus x squared is equal to 2. I think that's what it's saying. So in fact I'll type that equation because that's going to be a better way of writing the given. Yeah, 1 plus x times p of x squared plus 1 minus x p of minus x squared should be supposed to be equal to 2. And the problem says to show that there's exactly one p for each degree, which probably means that well, let's just see what happens, okay? So so plus 1. So p of 0 has to be 1 no matter what. And then if I take like the next coefficient, I want to show there's a unique value of c, which makes the identity true. So you know what? I feel like there's fewer minus signs everywhere if I write this in like this format. So I'm gonna actually like make 1 the quote unquote. I'm gonna write all my polynomials I think with degrees going up instead of degrees going down. Yeah, so anyways, like if you just look at the top coefficient, well, okay, what's interesting about this is that this is a degree 3 polynomial, but some of the coefficients just vanish, I think. Namely the, yeah. I think, so on the, as a function of the c, only one of the coefficients is not doing what thing you want it to. So let's see which one. I think it's probably the x squared coefficient because the left hand side is obviously even the way that it's written. So I only need to check coefficients like of. I'm gonna write triple equals just to emphasize this is true for every x. And what's the x squared coefficient? Like c squared. So the fact that I'm writing c squared bugs me a little bit, because okay, actually, you know what? This is stupid. I don't know why I'm writing it this way. Like this is just a factor 2 everywhere. This is equivalent to saying that. I'm sorry, I'm just being dumb. Like I just want so the x to the 0 coefficient of this is always 1. And the x squared coefficient, you're already promised the x to the first and x cubed. Well, you don't care about them. We only care about this one. This is supposed to equal 0. So if I expand this thing, it's like c squared and then plus oh frick 2c. Okay, alright, okay, so we always know that c equals 0, I mean, will correspond to a solution. So it's like, what is the other one? In this case, it's c equals minus 2. Can you just keep going? I feel like you might just be able to keep going. Because now let's look at this thingy, right? Well, okay, we know it's minus 2 specifically. So the next coefficient, if I call it cx squared, Again, I look at the... Why does this... Wait, I feel like I am clowning or something. If I want it to be odd... Wait, what? Yeah, the odd, okay, odd means all the even degree. So 0, 0. So, I guess my question is, why are there... Well, how come there's like a lot of solutions? Or, sorry, a lot of equations. Like, it feels a priori like... Really? Like, I get two equations, right? Because there's two... So, I have two simultaneous equations on C, and it seems a bit weird to me that the problem is telling me that there's going to be a solution that's common. Well, so there's a common root to both equations called C equals 0. We kind of already saw that. In fact, like... The top equation is like the top coefficient is the easiest one to compute because there's always only two terms, and it will give you c squared and then minus 4c. So I mean, we know what it has to be, right? Like, you just keep doing this. And every time it's like minus 2 times the previous one. Right? Cause okay, when I do the next layer, like, if I imagine doing the next layer, like 1 minus 2x plus 4x squared minus 8x cubed, or plus cx cubed, I mean, the top one, the top coefficient will be c squared plus 8c, right? So I feel like it's just like hello, like this is just the answer, right? Like in fact, you can describe it very concretely. P of x is equal to... Wait. I think I'm being a stupid head. I'm sorry, I'm being a stupid head. It's not true that the coefficients have to stay the same between levels, right? Sorry, never mind. Ignore everything I said. Today's really not my day. Sorry, ignore all of this. This is all garbage. Erase it all. Okay, this seems more right to me. There's going to be two equations and two variables. So this one, the top equation is always b squared minus 2a, that part. Minus 2ab, I guess. But the x squared coefficient seems super annoying. It's like... Oh, okay, so the 1 plus x is actually just like baiting me, right? Like it's really saying like I should really just focus on this chunk here, like the squared part. Also, I don't know why I wrote a minus sign. That doesn't make any sense. Okay, yeah, you know what? Yada yada. Alright. So let's suppose like p of x is equal to 1 plus a1x plus dot 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 plus an x dn. And then what are the coefficients, what are the constraints that we want? So the one is taken care of. The x squared coefficient is the sum of... So I need to start by writing p of x squared because that's really what's going on. So this is like 1 plus 2a1 times x plus a1 let me get this right. So this is what happens when you expand all the way up to like x to the n, which is whatever it is, and then it starts going back down to, so like the last one is an squared times x I wonder if I should just write a0 equals 1. Maybe that will make the equations a little... We're just going to set a0 equals 1, alright. Feels a little better. It's like a0 squared. You get the pattern, right? It's this thing. A and a0, x to the n, and x to the n plus 1. Plus a and a1, and then finally it's like an squared at the top. Okay, and then the problem condition is saying that this coefficient is equal to 1, and then these two add to 0, these two add to 0, and so on, which is a condition. I guess that is the thing you can say. You can rephrase this as a convolution, I think. Yeah, something like that. Okay, okay, this is a lot of equations. So I'm gonna write down the n equals like 2 cases first. So the n equals 2 case, what's happening is a0 squared equals 1. In fact, we're promised a0 equals 1, doesn't really matter. A0, A2. And then the top level says 0, A1, A2, plus A2, A1, plus A2 squared is equal to 0. Okay, so like I can't just actually plug it. Like if I sum all the equations, then, you know, it actually just says that a0 plus an squared equals 0, right? But it's a little better than that. It's like each of the little pieces take the Fourier transform. Honestly, you might be right, but I don't actually remember how the Fourier thing works. Like, I never actually properly learned this Fourier stuff, okay? I agree that seems like the right instinct in this case, but I don't actually know how it works. Anyways, what is the answer for 2? I do care what the answers are. Yeah, I have not finished listing out small cases, and that is indeed a thing I really should do. So I want so x squared plus x. So I think for degree 2 it should be this, right? Let me just double check that. Yeah, that should be correct. Which does factor, which is probably good to know. Even though I don't actually know what role the factorization is going to play yet. If any. It's possible the factorization doesn't play any role. Did I screw up degree 1 case? I think I screwed up the degree 1 case. Yeah, the sum of the coefficients is supposed to... Hang on, what? How did I screw up degree 1? Didn't I just do this, like... Oh, I'm sorry, I lied. The sum of the coefficients is not 0. The sum of the coefficients is 1. So, okay, my degree 2 answer is wrong then. Okay, I'm fine. I'll solve the system. Jesus. So A0 is 1. A2 squared equals... So A2 equals assume is non-zero. Otherwise, you just get the previous answer. So A2 equals minus 2A1. And my... Like, I agree that getting the first few answers is nice, but that requires me to actually be competent at doing calculations, which unfortunately I am... What? I'm not particularly good at A2 equals minus 2A1. Wait, are there not 2 solutions? So A2 is going to be minus 2A1. Then A1, 1, and then I'm told that... How can there only be 1 plus A1 minus 2A1 squared? Oh, I see, because all bit 0 is also a solution. So the valid solution, the quote-unquote new solution, should correspond to the minus 1 case, so... Wait, what? I thought I just agreed that was like not the answer or something. Okay. Fascinating. All right. Do I dare to try n equals 3? This is a geometric series. 1 plus 2x minus 4x squared is not a geometric series. Unfortunately. Like, it's 1 plus 2 minus 4 if I didn't mess anything up. Which I might have messed up. Like, someone should check this is actually an even polynomial. In fact, let me just... Yeah, I know. I want to check my work first, because as you have seen on this stream, I'm not very good at not making mistakes when I'm also trying to talk to an audience at the same time. Or if you want to tell me that this is right and I can... Degree 2 is correct. Okay, thanks. Alright, I'll move on to degree 3. I really don't want to do this, honestly. Okay, so I mean it's the same thing to start where so 1 and 2. I already dropped a factor of 2. And also, we're just gonna write a was 0. So the center equation is always the most annoying one. But because I have this red thing where the sum of the equations is clean, I can always ignore the middle equation and use that instead for the. Okay, so this is 0, 1, 2, 3, 4. So I need 5 and 6. Yeah, the top equation is very predictable. It's like a3 equals minus 2a2. Meanwhile, a0 is 1. So if I write everything in terms of the middle coefficients a1 and a2, the system that I'm trying to solve is... Okay, 2a1 plus a1 squared plus 2a2 is equal to 0. And a1 minus a2 equals plus minus 1. Right. Now, what is the solution to this? Well, I can add twice the second equation to kill off a2 now, right? So we don't care about that. So we should get something in just a1. Okay, so something's screwed because they all. Okay, sorry, I lied. This is plus or minus 1 minus 1. Shiba. They should say like in 0 minus 2 or something. So if a1 is 0, then everything's 0 at that point. Or that's actually, that might not be true. But I mean, we should recover every previous solution. So it's like either a1 equals 0, or a1 equals minus 4, or a1 equals 2, which is the previous, and then a1 equals minus 2. Which correspond to some cases. Jesus Christ. Okay. So the ones that correspond to things we already know about are this one that we saw and the... Wait. Huh? No, I screwed something up again. The sum of all the like 1 comma... Is 1 minus x correct? That does not satisfy this. Degree 1 is not. Degree should be 1 minus 2x. Okay, very good. We'll fix that. Okay, so that's this one here, right? This will lead to that, because this... You'll get 1 minus 2, 0, 0. So if a1 equals 2, and we're in the minus 2 case, this gives a2 equals 4, and hence a3 equals minus 8. which doesn't kill anything. This one gives a2 equals -4 and a3 equals +8. So something is wrong because one of these is supposed to not work. What did I mess up? One of these two should be an air set solution, but I don't know which one. Wait, a1 equals 2 does not lie in -4. What am I smoking? Sorry, this is actually a double root. Never mind. Okay, so we now know what the true solution is. And somehow this one is a double root? So it's interesting, you get this tree and then like weird shit happens with the tree. Anyways, the next solution is apparently one -4x squared plus 8x cubed, which is an answer that can happen. I will quickly verify that I am not stupid, which has not been true today, but 64, 32, 32, yes. Can someone tell me whether this is right, then I can move on with my life, or go on degree 4, alright. You know you have to. Do I have to? I don't feel like I have to, but it's probably good. Yeah. Seems a little silly not to. It's just, the system is so long, like... It just, it grows so quickly. Okay, so once again, the top equation. So for degree 4, yeah. The top equation will always just say a4 is -2a3. And then the next level will say... Wait. Yeah. The next level says, so this is the 8th and 7th. And the 5th and 6th are a2, a2, a4 plus a3 squared plus a1, a4 plus a 2, a2, a3 equals 0. Meanwhile, on the bottom, the x1 plus x2. So the nice thing is that the bottom equations, like, eventually are static. They don't keep changing on you. 2a1 plus 2a2 plus a1 squared equals 0. Wait, sorry, I'm gonna say that... Yeah, so... Yeah, the bottom equations eventually stop changing, which is good. I see. And then the center equation is the annoying one, but once again, I can do the same thing where it's really... If I take the sum of all of them, I can save myself the computational effort of one thing, and this is the system I'm trying to solve. Okay, so once again, wait, really? How come I had a quadratic in... No, I didn't. So A2 is actually pretty... A2 is always related by, like, this thing, and then the last coefficient is always related by a -2. Oh, God. Do I really have to do this? So okay, so far the sum of the coefficients is... Oh wait, what the hell? Is this like 2A Morse type stuff? Because the sum of the... Like, the sum of the coefficients so far, like, i.e. the values of p of 0 have been, 0, like, it's been plus, minus, minus, plus. There's gonna be some 2A Morse stuff? Oh no. Oh. It's not that bad. Like, I am annoyed that the values of p of 1 have been 1, minus 1, minus 1, plus 1. Oh, that feels really bad to me. Like, I was expecting it to alternate signs or something. I probably need this data point. I think it's easier to just grind through this than to try to guess what it's gonna come out to in advance. So, alright. So this is going to be a system in A3 and A1 because those are the variables I can isolate. So A2 is equal to okay, so that's A1 minus 4A1 A3 Okay, so that's one of the equations, and then this is like the ones that we'll actually solve are this one, and then of course the sum condition, which is a condition. Okay, so Jesus Christ, we're gonna A3 is better be non-zero. Yeah, at this point I'm not even going to like try to deal with the bifurcation. It's just we're gonna assume that so A3 is 0. Oh, A4 is non-zero. A3 is non-zero. Yeah. So this is something like A3 minus 4A1, and then this is minus minus plus A1 squared plus 2A1 times A3. So these equations are like almost the final form. In fact, this equation is linear in A3. Meanwhile, this second thing is like something yucky. It's like A1 plus minus A1 squared plus 2A1 over 2 plus, and then A3 minus A3. Alright, let me move this over a little because I'm going off the screen. Yeah, the 4C plus 1 totally killed us. Anyways, I need to solve the system. Does anyone happen to know the solution? Because I don't. Can anyone try to guess the solution? It might be faster than actually solving the system. Well, okay. So far, all the coefficients have been integers, so I think that's probably a pretty safe assumption, as if we're only trying to save if we're trying to save effort by just trying to guess the answers. In which case, a3 is equal to 4a1 times a1 plus 1 all over 2 squared. So there's like not wait. No, but if the solution are integers, right? Like okay, I agree. Like actually, NP hard. Like? It's not NP hard in the sense that like you can just solve it. It's just annoying. On the other hand, I really want a1 to be 1 because otherwise I don't think this is an integer. Because a1 plus 1 is co-prime to a1. Or it could be like -2 is the other possibility. I mean, wait, let's replace this with this, alright. Okay, great. I have it down to quartic polynomial in A1 with 2 possible values on the left hand side. I'm just gonna plug in A1 equals -2 because I feel like that has a pretty good chance of working. For A1 squared plus 2A1 over 2. Shit. No, that gives A2 equals 0. Actually, that's okay, right? Okay, it's not a1 equals -2. Let's try a1 equals 1. That's not an integer. Never mind. Oh my god. Did I screw something up? So A1, for this to kind of have a integer plausibility, A1 should be an even number, which is kind of what we expect. Okay, they've all been even so far. But then A1 plus 1 has to divide 4. Is it not A1 equals -2? Is it really not that? Did I make a mistake? I don't know anymore. Okay, I think I need to check my work. Alright, this is the 5, 5, 4, 3, 7. Okay, 7. Yeah, the blue should be fine, I think. Okay, the way you can debug it is I should be plugging in the previous polynomial, and then ignoring A4, because this only A4 only shows up in one place. So I can debug my work by plugging in -4 plus 8 and seeing if it works, which it doesn't. So something here went wrong. This equation's okay. Yeah, okay, I guess A4 appears in this one as well. But it's not. This equation is not okay. That's a real issue, is that this A3 equation isn't consistent with this previous data. So I messed up. Oh, but I substituted away A4. That makes it hard to check. Well, A4 equals 0 should... Fuck. Yeah, I definitely make a calculation mistake somewhere. This doesn't look right. What did I mess up? Oh, well, okay, thank you for just giving me the polynomial. Which equation is screwed? Someone wanted to debug for me? A2, A4, A2 is... Wait, did I mess up the bottom equation? The bottom equation's wrong? No, -4. Yeah, no, it's -12. Yeah, 4. I don't even know how to show unique. I can tell that the number of solutions is finite and it has this like tree structure, but like it sort of has a binary tree structure in all the examples that we've seen. Because each you get a bunch of quadratic like things, but the problem is I don't. Also, I'm still annoyed. Which equation did I screw up? A4 plus A4 plus A3 is minus A3. Yeah, I don't see the mistake. A3. Oh, I failed at canceling out A3. Okay, I see the mistake. This A3 shouldn't be here. That's why I got so confused. In which case A3, never mind. A3 is this linear. Oh god. Okay, anyways, at this point it's probably not instructional value because people already computed the coefficient. So yeah, let's just do it. 1, 4 minus 12 minus 8x cubed plus 16x to the 4. Okay, so there's a bunch of parts of 2 appearing everywhere, right? So I want to drop those somehow. In fact, I want to almost drop out... It doesn't matter. We'll think about it later. So we're going to apply the really legit strategy of engineer's induction and see if we can guess a pattern from numbers, which I don't like doing this very much because I feel like it's really shallow. Like it works sometimes, but it's really brittle. And like, I don't know, but I don't have a better idea right now, so I might as well see what happens when I do it. Okay, so 1, 4, minus 12, minus 8, 16. So we're going to divide out by powers of 2. 1, 1, 1, 1. I don't know what the heck is going on with the plus minus signs though. Did I really not mess up any of the plus minus signs? Like I find the... Yeah, and then the fifth row has a plus 1 sign. Minus 1, minus 1, minus 6. 1, minus 1, 1. This is not looking very good. Oh, wait, sorry, I messed up. This is not minus 6, minus 3. That's a little less horrifying. So, unfortunately, I think having one extra row would actually help a lot. I just really don't want to compute the next row. Like, given how much of a struggle bus it was to compute just the 1, 4, minus 12, minus 8, 16, I am not as optimistic about my ability to... Yeah, do the next one. But the other thing that is like some of the thing I was saying earlier, some of these equations don't change after a while. Like in particular, like for example, this like this 2a, like one of the rows is always minus the. Like we have some general rules. Like okay, for example, on the bottommost thing, like we always know this is 1. If this thing is called x, then like this one is always x squared. Minus 2x over 2, right? Or something like this. Sorry, I'm not dividing out by the factors of 2. I should do that. Or something. And then like if, but anyways, like on the far right, if this is like t, this is always minus t. And then what is it? It's like a1 over 2 squared. If I call this one like here, I'm gonna try to guess the next row. All right, how does that sound? I'm gonna guess this is minus 3 because I don't have a better idea for what it would be. This is the dumbest thing ever. So if this one is minus 3, what is the coefficient that comes after it? So this equation here says that a1 over 2, it's like minus something like this. Okay, let me index these zeroth column, first column, second column. So I have a feeling that the even numbered columns seem to have a fixed sign. Well, actually, in particular, this column is always like negative shit because it's literally. In fact, if I believe that everything in the first column is an integer, everything in this column is a binomial coefficient, right? I think in this case it has to be 3. And in particular, yeah, this column I have this feeling that everything in this column has to be they're all numbers of the form like negative something choose 2. Meanwhile, if I look at the 8th, God, this is just like this is so cursed. Okay, if I believe that, what do I need in order to make this thing sum to 0? Or not sum to wait, hang on. I guess what I'm really asking at that point is what are the values of p of 1/2? Like when I evaluate p of 1/2 at each of these blob thingies. Okay, I need a new table. Or do I want p of 1/2 or p of minus 1/2? I can't tell. If I imagine extending this downwards, what happens? If I believe that these are doing what I want them to, like this should be 3, this should be like -4, 4, and then this is like -6, -6, -10, -10, 5. These are all 1. Oh, I'll put the ones in green because I actually know those are ones. In which case, I feel like I have... Okay, let's see if I can get this. Shit. I ran out a little, the entries a little too early. But the fact that the second column is all binomial coefficients is strong. A3, what are the constraints on A3? Can I solve for... So... the problem is they come in pairs, but, crap. Okay, I actually just want to compute this number then. So if I believe these guesses, which I'm not very confident in these guesses, but that doesn't look good. I need in this table for the sum to be 16 minus 3 minus 3. 8x minus 3 doesn't work. What happens if I... Okay, this looks like it's plus minus 32. This looks like it's minus plus 16. We know this number is like some n, and this number will be like 4 n plus 1 choose 2, I think. Is that right? And I want a value of n that looks reasonable, that makes this thing sum to plus minus 1. So... alright, so I'm looking for a value of n such that plus minus 1, plus 16, 1, 16, 8x, and then like... Okay, so initially my guess was -3, but that didn't give me an integer. If I do +3, does that work any better? I think it does. I think if I do +3, it's okay. Wait, no, is +3 what I wrote? Hang on, I thought I just checked +3 didn't work. Am I a crazy person? Yeah, 53. Okay, I want -3 then, right? Is not -3 what I tried? Oh, I dropped a minus sign. That's why I'm confused. This should be minus. This should be minus. So this should be minus. So I think this checks out. Okay, actually, it looks like for chat is no, it's what's kind of up. Yeah, that feels good because the -3 is doubles up and then. Yeah, that feels good. I thought I tried -3. What did I write earlier? I don't even know anymore. Okay, so it's something like this. Like, okay, like, I don't. Okay, so I still don't really know what's going on, but I know that the second column consists of binomial coefficients. Like those are things choose to. Yeah, but like the next row has to be like this has to be 3, right? And then this has to be +6. Like I feel like this is the completion of the yeah, this feels really right. Like I think these are the first 2 columns. Okay, meanwhile people are saying that there's trig happening, which I have no idea why there's trig. Are you saying that like these are like Chebyshev things? Chebyshevs of the third kind. That's the worst thing I've heard all day. Okay, alright, let me catch up. I see. You're telling me that these are Chebyshev polynomials, with some different scale factors, and the idea is so this first of all requires me to actually remember what they are, but like let's see. That's a pretty big spoiler actually. Sine theta, or cos 2 theta is these are the ones that I happen to still remember off the top of my head. Probably don't remember many others. So I bet once I see what cosine 4 theta is, I'm gonna have I'm going to be enlightened, right? Also, did I screw that up? I fucked that up. I'm sorry. This is 2 cosine square minus 1. One minus 1. Yeah, I don't, okay, I don't think I'm actually gonna get this anytime soon. Substitute out as... Is it always the C that factors out? It's always the leading term that factors? Because if so, that's really good. Like I noticed that at the top. And where did I write the general equations? I see. Okay, the leading term will always factor. Really? That's so. Yeah, I mean, if that's correct and the leading term is always factoring out every step, and we then, and we can check this, then we actually, I think that lets us bypass all the trig, right? Because it actually does imply like unique something something, or maybe it implies that most one solution. It's possible the uniqueness seems kind of trivial. Really? I don't see it. All right, let me do the thing that was suggested though. That's about recurring down the So the top equation says an squared plus 2ana minus 1 equals 0, which implies how does knowing p0 equals 1 let you solve for the x to the 1 coefficient? I'll just say 2. Okay, so you substitute in a minus 2an, and then the point is everything is, yeah, so an minus 2 will be some oh my lord. Wait, I'm confused now. Like an, like the next tier, like you had this thing where you're like, let b equals 2a plus 4. But that's like relating a and b, right? And I don't know. Like I feel like for large n, it's not. Like it's not a single new variable each time, is it? Or something? Wait, I'm a little confused. keep going, but I don't understand what keep going means, right? Because like this thing says that if I'll even solve it explicitly. So you substitute in the so what we're doing is just dropping a factor of an, right? So it's like 2an minus 2 plus 4an plus, and then an, this is a minus 1. An plus an minus 1, it's like minus an, drop it. Like you get an minus 2 plus an minus 3 here. Which is, oh, yeah, I mean, this is the thing that you got. So this is telling you that like an, why the hell? I should be getting the same thing as you because I haven't run out of terms yet. Or maybe I did. Hang on. How come the a sub n minus 2 canceled? That's not supposed to happen, right? Yeah, I mean, it's not the case. Yeah, that's not supposed to happen. Yeah. Damn it. What did I do wrong? Oh wait, I'm just stupid. Okay. Yeah, there's a 2 in front of the yeah, but now, yeah, so you get this as at the next level, but now I don't know what it means to keep going because your next equation will have you get 2 new variables at the next level, right? Which is an minus 4, an minus 5. But you already have like in addition you had this an that you keep factoring out, which is fine, but you also have this an minus 3. So like it seems like the number of variables grows. Like the example we did that you showed with ABC like has, because n was small, like n was equal to 3, like a0 didn't cost you anything. But I don't think that will work for larger n if you try to go top down like this. Once n is strictly greater than 3 is kind of, Yes, I have no idea. I can either see the construction even with the nudge that there's like a trig polynomial involved, nor do I see how to check the uniqueness. Okay, Twitch chat says let x equals y plus y 1 over y. So we want this to also be even. You don't want a factor of 2 in there or something? Oh yeah, wait, there's over 2. Laurent polynomial ring 4y is a unit, and alright, where is this going? So the claim is that this is even, or sorry, is odd in y. Oh, what? It just it forces. Are you? The heck is this? Oh, you're saying to plot the y thing into this equation. Sorry, I didn't quite understand. Let me try that again. So, you want the unique what the? Excuse me? Wait, I'm a little distressed. So the claim is that this identity factors as like. Wait, can I just let like. Y squared 2y 1 y, okay, so it's like y plus 1 times p of y plus 1 over y squared minus y minus 1 squared p y minus 1 over y. What the this substitution happens to come from airfoil theory. All right, great to know. Yeah. That's definitely the inspiration that we need right now. Yeah. So what happens after this is that so the right hand side factors, and then this guy has to be like. Yeah, so this is like a monomial times something, and then this is like some other monomial times some other thing. So you can set the difference of squares equal to... What the what on earth? Okay, that is a thing you can do. Sure. So, what? Excuse me. Doesn't uniqueness follow by expanding? I don't follow that. I can't tell how that's happening. I forgot. Yeah, actually, I should just type this up now. This is going to work, because it's going to work. So I should just, properly typeset it. You forgot a negative sign. Which minus sign did I forget? In P. In P? Sorry, I understand. Yeah, this should be a minus. Minus. It does break the approach? Oh, does this kill it? What is K? Like, can I get K to be if I plug in y equals I into this? Okay, let me just start typing. If this doesn't work, if this doesn't work, I'm gonna rage quit the problem because I don't think I'm gonna get it at that point. But I generally feel optimistic about this approach. China TST 2007. What are the coordinate? What's the problem number for this? While I'm adding it to the database. No idea. Got it from. All right, that's fine. We'll deal with it later. So we're gonna let x equals x equals half y plus 1 over y. Then the above equation can be rewritten as 4y is equal to let me do this step a little more explicitly. These should be 2's and not 1's. 4y is equal to I'm gonna just use big here. Y to the d plus 1, okay, y to the minus d. I agree it's probably not solvable immediately, but it should be solvable eventually, I think. So can someone quickly show that k equals 2? Because automorphism thing, what does that mean? Can I just look at like the leading coefficient? Y maps to 1 over y. Oh. Yeah. Has positive degree. Okay, I'll just drop the word positive. It doesn't matter, right? Like, okay. Hence it follows that plus minus 2 y to the d plus 1 plus y to the minus d equals y plus 1 . Can we make D positive somehow? Just replace D with 1 minus D or something. Wait, That's a little confusing to me, actually. That seems like it doesn't... Like, like, when D equals, You know what? I would rather just have plus minuses. It's a little less annoying that way. Or no, it's. Yeah, actually the plus minuses are fine. And no, but it's like I get a plus minus here. P of x oh god, the signs are so stupid. Minus x. No. Oh, the plus minus signs on the right hand side cancel out, so that part doesn't matter. Yeah, the point is that you add them, and it doesn't matter which ones. Okay. Which one's which? Okay. So this is always plus, which is what we want, because otherwise it's super annoying. Okay, and then I have to actually do this division-ish thing, which is like. D minus 1. I probably flipped the signs. I think this is just real poly. Like this is the most. Oh, actually, it's a little. I don't know. I don't. This probably is something. So anyway, the theory of Chebyshev polynomials now guarantees that y to the k plus is a polynomial in X for each k at least 0. Yeah. Wow. Okay. So. That we see there for each degree is exactly, there's at most, there is a unique choice polynomial P Could I just use N instead of D at this point? The plus minus signs are super, super annoying. Am I off by a factor of 2 somewhere? I feel like I dropped a factor of 2. So this choice of polynomial p will also this is actually easy to see, right? If this is true, then well, p of minus x is literally maybe I shouldn't use k. I'm gonna use 2 epsilon. Just so I can yeah, and then no, yeah, the condition p of 0 is equal to 1. We find yeah. Let's find this ring. I feel like I'm sending a submission to anti-problems. Hello, are you stay alone in the US or with family? Wait, what? I go to school at MIT. So I guess alone, question mark? Actually, how obvious is this? Well, p of minus x and p of x should... I am in... I mean, I'm in Boston for those of you that haven't figured that out. Can anyone join your Otis program? I mean, yeah. Just go to the website. There's application instructions. So the choice of polynomial p we just mentioned will satisfy the entire system, ergo will satisfy the desired condition. In other words, the unique possibility for p does indeed work. Yeah, this is the last thing that you have to do, I think, which is like you looked at the system and you're like, okay, there's a unique p of x. Once you choose an epsilon, there's a unique p that makes this true, and that p also satisfies the second equation, which when you put those two together implies yeah, somehow I want to write like if and only if, and then like this entire chunk as like a single system. Like it's like this if and only if this. I wonder if I could do that. Let me see if the typesetting will let me do that. I haven't used aligned in a long time. No, actually I think it's not worth it. I'll just leave it like this. Wow, okay. That was good job, team. That is